Okay, the recording is now going, and that's great. All right, so welcome everybody this evening. Tonight we're going to talk. I decided to morph the last few weeks together, and we're going to be talking about some engine diagnostics and scan tools, and a little bit of electrical. And what we don't finish up tonight, we will finish up last week for our last lecture. Tonight it is class number 15. So this is lecture number 15, and next week will be number 16. So we are getting to the end of everything. In fact, let me go ahead and clear these drawings, and let's go over. I'm going to put this in student view, and here we go. It's getting loaded now. So here we are in student view. And if I go to our calendar, let's see what we have here. Here we are, the month of May. And yep, stuff finishes up that quickly. Man, I'm going to get this drawing tool going again. So here we are tonight on the 11th. Our class 15, and then our very last class we're going to finish up lecture and just wrap everything up on the 18th. And then the 19th is the last day of the semester. Most of the assignments you can, this says like they're due at the end of the semester. However, I want to say I've set it up so you have a few extra days to work on stuff. Like it will still take the assignments through the end of the week. A lot of that is still live. In fact, let's click on the final and let's see what we got here. So yes, you can see if I get rid of my scribbles, you guys can see that it's available through May 21st, although it's due the last day of the semester. You have a couple more days to get it done. Okay, so anyways, 50 points, 50 questions. It's all stuff we've talked about. Like if you guys have been plugging along on those quizzes, those 5-question quizzes all week or all semester long, you shouldn't have any problems with that. I'm going to go back to that course calendar. So that's how quickly stuff is closing up on us. It seems like the school semester comes to a pretty fast end. Usually when we're in-person classes, yeah, you kind of feel the end coming on. It's like, oh, I got to get my projects wrapped up, get them out of the shop. This is a little different. Boom, it's just over. But there we have it. You can see that, all the extra credit things. Really, the big assignment that's due on the 19th is the final exam. And then there's a lab sheet on using a scan tool. Pretty much everything else is due before. So, with that, now that we've looked at the calendar, let me go back to our course and let me show you guys a way you might want to look at stuff. If I go to grades, and remember this is in my student mode, so I haven't done a lot of things as my test student, but it's a great way to see anything you haven't done. So anything that comes up missing is an assignment you haven't done. You can see out of the stuff that you have done, what points you've received. And of course, at the bottom of this, you'll find your total grade in the class. Now, don't worry, your grades by and large are much, much better than my test student here. But anyways, it gives you an idea of where you're at. Some of you guys might be so far, with so much extra credit and everything. I did go through and update your grades. You guys might have so much stuff that heck, you might not even need to do the final or the last few assignments. But anyways, so here we are back on the home screen. But actually what I'm going to do now is I'm going to change my screen share to tonight's presentation. And now that I've done that, I'm going to get this thing scrolled to the top and get stuff fixed up here. All right, we'll move that out of the way. And let's clean this up a little bit more for you guys. So I'm going to get that up there. And now we will share it one more time to get it looking really sharp for you guys. All right. So what I decided to do was kind of merge the last 2 weeks of lecture topics to kind of maximize things for you, because the last 2 weeks are electrical and engine diagnostics, and each one of those is a semester-long class in itself. In fact, electrical at AR, we have 2 classes, an A and B. I mean, those are very vast subject areas, okay? So we're going to kind of morph them together and make it a 2-week deal, okay? So basic troubleshooting techniques. We started talking about this a little bit last week, and we talked about how every engine needs heat, fuel, and air in order to run. But let's dive in a little deeper. First of all, as you guys know, hey, cars can have a lot of problems, right? They can have a lot of problems. So you could have a no start. And last week, I talked about how if you have a no start, a no start that's a no crank, right? You turn the key, nothing happens. That's totally different than a no start where the car cranks over but it just doesn't fire up, right? Those are 2 different things. You could have a car that runs rough or has a lack of power, right? Now that may or may not include a check engine light up on the dashboard, okay? You could have a car that maybe overheats as we're heading into summertime here. We could have a car that, hey, this thing feels like it runs good, but I had to get a smog test done, and guess what? It failed smog, right? So there's all kinds of things when it relates to your car and getting that engine to run correctly that come into play here. And it's, it's a pretty vast area, and it's something that, I've studied this, all of my adult life and then some, going on, well over 20 years. So anyways, there's a lot of stuff to it. So as we talked about last week, a car, the internal combustion engine on your car that we talked about, 4-stroke cycle and all that stuff in previous weeks, it's got to have spark, fuel, and compression, and everything has to happen in the proper order, right? The proper sequence, the proper timing in order to get this engine to run. So, there's a lot of stuff going on there. Now, I'm looking at, looks like we've had a few people join on the line, and that's awesome. I see Lonnie jumped in with us. It's good to have you here, Lonnie. And again, we have Rebecca and Tim and Jacob, Tyler. It's really good to have you guys here. So we're going over some diagnostics. And again, we're relating, we're basically merging our electrical and engine diagnostic presentations together to get you the most out of this thing. So one of the things that I mentioned last week that's super important is to not forget to check the battery. And it might seem kind of silly almost in a way. But it's really, really important. In fact, what will happen is, you'll think the battery's just fine, and maybe it's not. Maybe it's just getting a little weak. If the battery voltage drops below 10 volts, and actually I've found it, if it drops below 10.5 volts, that the computer may not be able to function properly and do its job. So, here's a picture of a car battery, and it's cut away so you can see on the inside there. And inside a car battery, guys, you have a mixture. There's liquid in here, and that liquid is a mixture of sulfuric acid and water. Okay, so sulfuric acid and water, and then inside you can see that there's all these plates here, all these kind of paper separator looking things. Those are plates, and the paper separators separate out the positive plates from the negative plates. And then those plates are put together in groups, and they ultimately get connected to the positive post and the negative post of the battery. So this battery, guys, you actually have a chemical reaction that occurs inside here, and it uses that to make electrical voltage. Well, these batteries typically have a lifespan. So if I get my text tool up here, yeah, let's see if I can do that. Let's see, text tool. And all right, if I get my text tool going, what I'm going to say is the lifespan is usually actually, let me do this, 3 to maybe 6 years car battery life. And if I just want to make sure you guys can see that. Oh, you can't. Hang on a second here. Now let's make sure that you guys can see that. I don't know if you can see it or not, but 3 to 6 years. That's the life of our car battery. With most batteries live in about 4 or 5 years, right? So 4 years, 5 years. So one of the things that I look at when I have a car that maybe doesn't start, or I look and I see, well, how old is this battery? If it's 4 or 5 years old, it's kind of suspect, right? And I have here, know the battery volts before any diagnosis is performed. So you could have a car that doesn't start. I've even had a car, believe it or not, I had a car that failed smog because of a defective battery that was constantly draining the electrical system down. So anyways, very important, check the battery, okay? And what this is for us is this is a good segue to jump into some electrical stuff, okay? We know that battery is on that car there so it can store power, and that way I can walk up to the car and start my car in the morning, right? But what really is that power? A lot of times you hear people talking like, oh, I don't have any juice, okay? Well, it's not really about juice, okay? The electrical terms that we need to know are voltage, current, and resistance. Now, those relate really well to water. And the reason we like the water relationship here is, guys, because when you relate stuff to water, it's a physical thing that we've all experienced. We know how water flows out of a hose. Like we can relate to it, we can see it, we can feel it, that type of thing, right? Where electricity is a little bit tricky. I can measure it with a meter, but I can't I can't see it, right? So anyways, voltage is like your electrical pressure. It's your pressure in your water hose, if you will. Okay. So if I have a water tower here, that voltage is my water pressure. Okay. It's electrical pressure though. Current is like water flowing through the hose, and resistance would be a kink in that hose that would restrict the flow. Okay. So again, what are these terms really? Well, voltage is electrical pressure that causes the electrons to move in an electrical circuit. Okay. Current is the flow of the electrons through the wires, through our components, whether that's an electric motor or a light bulb. That's what current is. And then resistance, well, resistance is any opposition to that flow. So if there's any opposition to the current flowing through the hose, that's going to be resistance. And I don't care what electrical circuit you have, any electrical circuit is going to have, if it's operating, you're going to have some voltage, you're going to have some current, you're going to have some resistance, all playing out in that circuit. Now, what are some of the things in a basic electrical circuit? Well, you're going to have a power supply. For us in our car, that's our 12-volt automotive battery, right? You're going to have a load. That could be your starter motor. It could be a headlight. It could be the car's computer system or an electric fuel pump, right? Protection device Well, there's usually some type of fuses in that circuit to protect the wiring. I'm trying to draw in a fuse right there. Conductors, those are the wires themselves. And I usually have to have some type of control, some type of switch to function that circuit. So there's going to be some basic parts to build an electrical circuit that you need to have happen. On top of that, there's different ways that you can wire up these circuits. You can wire up in series, or you can wire up in parallel, or you can have a combination of the two. Okay. And in the electrical class, we spend a lot of time diving into the different circuits and testing them. But to show you, you know, I'm going to show you a picture of like how it would look more on a regular car. Now, keep in mind that each type of circuit has its own characteristics regarding, you know, how the amperage flows through the circuit, what's going on with the resistance, and how voltage drops happen throughout that circuit. So a good example of a series circuit that has a bunch of the common components would be this one right here, guys. So with this circuit, what you can see here is that we have a battery, right? We have our fuse, that's our protection device. We have a switch, we have a light bulb, and then on our cars, what we do to really to help us minimize the amount of wires that we have on our circuit is we utilize this ground connection. The, you know, conductors or wires, right? They're you know, good materials for conductors are things like copper, aluminum, steel, right? Well, the frame of our car is made out of steel, so that becomes a pretty good conductor. So instead of having to run wires all the way out to our component here and all the way back, what we can do is tap into that ground or that vehicle frame and use that as the negative connection back to the battery. And so that's how we do that. So where it might look something like that on the car, on a wiring diagram, what would be done is it would be drawn like this, where this weird looking symbol with all these lines is the battery. Well, we saw kind of a cutaway of a battery. That was a series of plates, right? Positive plates and negative plates. Now, if you've ever lifted a battery, you know, hey, they're pretty heavy. That's because what's on those plates is lead. It's sponge lead on the negative plates and lead peroxide on the positive plates. So there's our battery. Here's our fuse. There's our switch, and there's our light. And this is the schematic symbol for ground. Okay. So that's a good example of a series circuit, meaning that there's one path for current to flow. The problem with this series circuit, if anything opens up, then the whole circuit goes out. Most of the circuits on your car are going to be a parallel circuit or maybe a series parallel circuit, a combination of those two. So if this is a parallel circuit, instead of these being resistors, if these are two headlights, if one headlight burns out, guess what? The other headlight's going to keep going. And that's why we tend to run our automotive circuits in parallel so that they have more than one path for current to flow. And each device then receives its full source voltage, and each device has its own path to ground. Now, I need to put some terms up here. We talked about voltage, current, and resistance. I need to talk about what do we measure this stuff in? For instance, voltage, that's an easy one. It's measured in volts. Current, though, current is measured in A or amps. So now what we're going to do is we're going to kind of shift over and look at, you know, well, how would this look on our meter, and how could we do some tests with the basic multimeter? And you could have anyone. This is like a $40, $50 meter that you get from the local auto parts store. And in one of our classes, we feature this snap-on meter that's like a $400 meter. So we went from a $40 meter to a $400 meter. Here's a meter that you can get for just about $10 that will do a lot of electrical tests. And to get started, this is probably really the only thing you need. It can do a lot of the basics that we're going to be talking about tonight. So let's look at these meters. Okay, so we tend to call them a multimeter, or DMM for digital multimeter. Sometimes if you're old school, you might call it a DVOM for digital volt ohm meter. But because most all these meters, even this cheap one I have here, can measure amps, it's really more of a multimeter. So it can measure voltage, that's electrical pressure measured in volts. It can measure the current flow, which is measured in amps, or it can measure resistance that's measured in ohms. Okay, so again, voltage, current, and resistance, those three properties: voltage, current, resistance. Voltage is measured in volts, current flow is measured in amps, and resistance, that's measured in ohms. Okay, and on your meter you'll see a little Greek omega symbol that I'm trying to draw out right here. So what do those look like on your meter? Like, what would you select on that dial right there? Well, notice that there's a V right here on this meter face, and there's a V right there, right? Well, this V with the wavy line that goes like this is for AC volts. And AC volts is typically what you'd have in your house. Okay, it's alternating current. It switches back and forth, and if you put an oscilloscope on there, it would look like that. We don't use that feature too often when we're testing cars, but if you, like I said, you were testing electricity at your house, that's what you'd be on. Okay, your car, because it uses a battery, it measures volts DC, so they draw it with this straight line with a little dashed line underneath it, meaning that, we're going to have the current, the amps, is going to flow from positive to negative. It's flowing in one direction. Okay, and there's a couple different thoughts, whether it's conventional current flow or electron flow theory, but for our class, we're going to say it flows from positive to negative in one direction, and that's DC, or direct current. Okay, and if you're measuring volts on your car, that's the most common measurement you're going to do. So if I back up a couple of slides here, you can see it saves a lot of my scribbles here. When we talked about, hey, let's check the battery, I would want to hook up to that battery, and I really want this battery to read not just 12, but 12.6 volts. Okay, because that's what a fully charged battery for a car, lead acid battery, should have, 12.6 volts. Believe it or not, if you walked up to that battery and you tested it with your voltmeter, set the volts DC, and it only measured 12 volts, that battery is really only at a 50% state of charge. Okay, so you really wanted to say 12.6 volts. And if you kept your meter hooked up as you were cranking over the engine, I would want the voltage to stay above 10 volts. Really, I like it to stay above 10.5 volts while I'm cranking over the engine. Okay, so voltage, current, resistance. Remember, resistance, that's the one that's measured in ohms. All right, current flow is measured in amps. We talked about the circuits. We'll fast forward back to where we were. So we want volts DC for testing our car, and it's the most common measurement we're going to do. And here's an example. Like if I had that basic series circuit with the light, before the light bulb, my voltmeter should read 12 volts. After the light bulb, if I hooked up my red lead or positive lead to the wiring going to the light, and the other lead would go to the chassis or to ground, that, you know, that it should read 0 volts at that point or really close to it. Okay. So again, voltage, what is it? It's like your electrical pressure, if you will. And so it tells me, hey, before the light, I have pressure, and then I drop that pressure when I go through my load, when I go through that light. Okay. And that's really how it's supposed to work. I should have voltage before my component, and then after it should be relatively close to 0. So the higher the voltage, the more current flow you could have, right? Like if instead of a 12 volt battery, I had a 300 volt battery, well, I could flow more current, right? So that's why like an electric vehicle, it doesn't just rely on a 12 volt battery. I mean, it still has a 12 volt battery to run the computer and stuff, but the actual traction battery that propels the car, it's going to have 300 volts or so or more to give you the pressure you need to drive that car down the road. Okay. Now it says the higher the voltage, the more current flow it can create. Here's the thing, is it's really all about the current flow. It's the flow of the electrons. It's the flow of the current, which we measure in amps. That's what actually does the work. Okay. But if I don't have any voltage, if I don't have any pressure, I'm not going to get any flow, right? I'm not going to get any amps. So it's kind of a unique relationship there. So I need the voltage to get the amps. It's really the amps flowing through something that makes it work. So I always think of the amps, the flow of electrons through a little light bulb filament. That's what makes that light bulb grow or glow, not grow, but glow and produce light for you. Now, anytime you're flowing electricity through anything, whether it's a wire, whether it's a light bulb, whether it's an electric meter or a fuel injector, remember that component is going to have some resistance. There's always some opposition to the flow. How do we test for resistance using our meter? We go to that little Greek omega symbol. Every meter will have some type of, resistance symbol. So if I put this one up on the screen right here, you can see that if I put my lead over there, I'm over in my resistance zone there. Okay. So when I do that, I have to have my circuit turned off and my power supply disconnected, because when I'm testing for resistance, I'm sending power out one lead of my meter and I'm getting it back on the other lead. So if I touch these two leads together, this is where I can measure the resistance of my multimeter leads. And this one says zeros, which is pretty good. I'll go down to the finest scale. Let's see what it says. So 0.03, 0.05, something like that. All right. Now remember, amperage is the flow of electrons. That's what it's really all about. That's what does the work in a circuit. And we would measure that going over here to these amps sections of our meter. And it's pretty tricky. We not only have to go over to the amps section, but you got to take the lead out and move it over to another spot on the meter to measure amps. So amps probably is one of the more difficult measurements to do. Your circuits and your meter are more vulnerable when you're measuring amps. Fortunately for us, the most common thing you do really is measure volts. So I usually, stick to that for my default is keep the leads. You notice that there's different ports that the leads go in. The black lead always stays in the COM port there. So I'm going to take the leads out of one meter and put it in the other. So the black lead goes in the COM port and he pretty much stays there. But the red lead, he can move depending upon what I want to do. Most of the time, 95% of the time, I'm measuring volts or ohms. And so he's going to go over here. Every once in a while, I want to measure amps and I have to move him to one of these other spots. Okay. I never want to leave my leads that way though, because I could damage an electrical circuit or my meter if I hooked it up wrong. So I always leave the leads where I'm in the volt spot and the COM spot. Okay. So remember we were talking about diagnostics, and we kind of took this sidestep for electrical because, you know, the one of the first slides that says, hey, make sure you got a good battery in the car. That battery should measure 12.6 volts. Okay. So I would always, you know, it's a good thing to do. Hey, I'm going to test the battery voltage. It should read 12.6 volts, and that's 100% state of charge, or SOC. Now, if you have a car that's, you know, running weird, or it doesn't start, or it's got a check engine light on, you know, I actually, this semester I've been teaching a scantool class, and I've been talking to those students a lot about building a diagnostic process, like a step-by-step process to go through to help you figure out problems. And a lot of times people think, hey, I'll talk to the computer on the car. Well, what the scantool is could be a little interface like this one right here, could be an actual, you know, multi-$1,000 tool, but it basically allows you to talk to the computer on the car. It's a tool that allows you to scan or talk to the computers on the car. Well, guess what? That scan tool doesn't replace your multimeter. It doesn't replace a lab scope for that matter, or any other dozens of different diagnostic tools like a compression tester or anything else. But it does allow you to talk to the computers, and from that, you can do a lot of diagnostics. Why? Because built into our cars these days, and I'm going to say these days pretty loosely, is, you know, over the last 20, 30 years, as we put computers and stuff on our cars, we've also put on them a onboard diagnostic system. Okay. So, you know, you guys have learned in automotive, we love our acronyms. So OBD, that stands for onboard diagnostics. And this slide kind of shows you how it evolved. In the 80s, we had things like fuel injection, replaced carburetors on cars. All right. We were doing smog testing and stuff. We had to use our multimeters and stuff, but we got some codes and stuff from the computers. Well, that evolved in the mid 90s to have what we call onboard diagnostics generation 2, or OBD2. So if your car is a 96 or newer, you can get a relatively inexpensive scan tool interface like this one right here, and do a lot of scanning, a lot of talking with the computer to help you figure out what's wrong with the car. Keep in mind, if your battery's dead, you could get a bunch of wrong information from the car. So that's why I talked about that stuff first, is always make sure you got a solid battery in that car and the voltage is up. You're reading 12.6 volts or more. If you're not, you'd be smart to charge up that battery. Now, one other note on talking to the computer. When I talk to the computer with my scanner, whether it's a little interface or like this nice snap-on scanner right here, we call that backdoor information. Why? Because it's processed information from the computer. And that means that sometimes the computer misreads stuff. It's like you're seeing whatever the computer thinks it's seeing and then decides to tell you about it, right? It's, you know, it's like if you know, get a story that's from a friend of a friend, like over time, the story changes. Well, because we've used our scan tool to talk to the computer or powertrain control module, and then he got his information from the input sensors, you know, stuff can change in there. So I always look at scan tool data with a little bit of skepticism, because sometimes it can throw you astray. But if you understand how to leverage it, it can really be really useful. Now, that being said, there's all kinds of different levels of scan tools. Like I was talking about this cheap interface. And here's a whole bunch of these inexpensive interfaces. I really like this this one right here. It's the Vicar one. It has pretty good connectivity to both Android phones and iPhones and stuff. But there's a reason why the folks at the dealer have scan tools that cost $8,000. They can do a lot more features and really tap into those computers. And those scan tools will be manufacturer specific. They're going to have all kinds of things that they can do, but they also cost several hundred, if not thousands of dollars each year just to keep the scan tool working. With these little generic scan tools, we're basically going to be focused on things that ultimately affect the emissions of the vehicle. So you can't get all the information. You may not be able to get things like wheel speed sensors and your airbags and stuff, but you should be able to get the stuff that relates to your engine and would cause a check engine light or cause it to fail smog or run weird, stuff like that. So if you have a car that's running poorly or it doesn't start, or if it has the check engine light on, and that light's going to look something like this, might have a picture of the engine, it might say service engine soon, or it might say both. We call this the malfunction indicator lamp. And so if that light is on, guess what? That computer has set some codes. And one of the things that would be smart for you to do is go in there and talk to the computer with your scanner. So here's a handheld scanner, similar to what you could probably buy at your local auto parts store, and it's pulling a code, right? So you want to pull that code, whatever that is, and figure out what's going on there. Now, just because it sets a code doesn't mean that that's definitely wrong with the car. Like this is a good example. I have a P0301 misfire code on cylinder 1. Does it tell me why it's misfiring? No. It could be a defective spark plug. It could be an engine that has low compression on cylinder 1. It could be dozens of different things. A clogged fuel injector. Doesn't tell me exactly what the problem is. It tells me that it's set a code. It means that like the computer's looked at it and something ain't right and it's related to this. It's up to us with our multimeters and our automotive smarts to figure out, why that code is being set. Okay. When I see that the check engine light's on, this malfunction indicator lamp or service engine soon, whatever you want to call this thing, I think, okay, the computer's upset about something. I'm going to get my scanner and see what he's upset about. And that's what I'm doing when I pull the code. So one of the things that cars 1996 and newer have, our OBD2 cars, is they have what they call a freeze frame. So they can tell you what happened, how the car was being driven when the code was set. And that's a really strong thing to do. So this car was going 27 kilometers an hour. It was at 3,000 RPM. If I scrolled down, I could see how fast it was going down the road, all that type of stuff. Okay. And not only does it set codes, sometimes there's codes that aren't full-fledged codes. We call those pending codes, and you can check those as well. So there's all kinds of data that you can get from the computer. But if this data looks kind of complicated, that's because it is kind of complicated in that we have whole classes that are semesters long that teach you about what all the data PIDs are and what they mean and how to read them. But these are all different parameters. Most of these relate to sensors that are on the engine. So this one right here says engine RPM. That's going to largely come off your crankshaft position sensor or your CKP sensor. Okay. In fact, we talk about like prioritizing these data PIDs and just selecting the most important stuff. So the scanner can definitely give you a direction to go. In my scanner class, we've spent quite a bit of time with these little cell phone based interfaces, and the ones we use work with the ELM 327 protocol. And that's what we have in the AT100 class as well. We talk about an ELM 327 communication protocol between the or scanner protocol between the scanner and your cell phone. And it basically uses your cell phone, and you can get different apps. The one that we've been using is this one called Car Scanner Pro. It's available for both Android phones like mine or iPhones. And it works pretty good. In fact, this is what it looks like. And it can look at your codes. It can look at that freeze frame. It can look at all the different sensors. You can record data. There's a lot of stuff that it can do. You can even graph out the data right here. You can make sure your monitors have ran and you're ready for a smog test right there. So there's a lot of things that this tool can do that relate to OBD2. And so your activity actually for next week, if you're doing that little worksheet, it asks you to scan your car. Well, you could get one of these interfaces for usually somewhere between $20 to $30. But the other thing you can do is go to your local auto parts store. Almost every store, whether it's O'Reilly's or AutoZone, or they all offer a free code scan. So you could ask them to hook up their scanner and check for codes and look for data. And they'll probably have a scanner that maybe looks something like that. And you can get some information on there. Definitely, it's a fun thing to do. If your check engine light's on, you're going to figure out, why is the computer not necessarily what's wrong with the car, but what's the computer upset about? Whether it's a misfire on cylinder one, whether it's fuel trim issues, whether it's a catalytic converter. So anyways, the scanner is one more tool to your diagnostic toolbox to help you figure out what direction to go. And there's a lot of stuff with that. So if I had any drivability problem and this light was on, one of the tools what I would grab right away, I would still check and make sure that I had a fully charged battery and all that stuff, but I'd grab one of these scanners and I'd check to see if I had any codes. So I have here step one, verify the complaint. Maybe it's I test drive the car's running poorly, and I verify, oh, the check engine light's on or the mill is on. Hey, let's pull the codes. And so here we're pulling codes and checking for pending codes by clicking this icon right here. And in this case, that's the code I got off of a vehicle I was recently working on for an O2 sensor heater. Now, does that mean that the O2 sensor is definitely defective? No, it just means the computer's upset about it. So that could be related to a blown fuse on the car. It could be related to a bad sensor. It could be any number of things. Even an exhaust leak could cause that code to be set. I then go in and I review the freeze frame data. I look at, hey, how was the car being driven when the code was set? This car, the engine was pretty cold. It was only at 86 degrees Fahrenheit. It was going 1100 RPM, so it's not a lot of RPM. And, it's just kind of cruising down the road. It wasn't going very, very fast when this code was set. Here's that same scantool app. It shows you how I can graph out the data. So here I'm looking at my O2 sensors, bank 1 versus bank 2 to see if that supports the code. And quite frankly, right now it's inconclusive. I wouldn't say from that if I could tell if O2 sensor number 1 was reading really different than O2 sensor number 2. So one of the most important things that you need as a technician figuring out cars is you need good service information. In our class, I've given you our codes to ShopKey, and you have access to those for a few more weeks, and then our codes will probably end up changing. But man, if you have a check engine light, you pull some codes, look that stuff up in ShopKey. I did that for this O2 sensor one. It tells me how the sensor works. It tells me how the code is set, all kinds of good information. Having the right information is imperative for you guys to figure out cars. Now, for that particular code for the oxygen sensor heater, I ended up doing pinpoint testing, and look at this, I'm using my meter again, and I'm getting out the wiring diagram. So both things that we were kind of talking about tonight, and I tested it out and I actually found that yes, the O2 sensor heater was defective, and the proper repair was to replace that that O2 sensor. Whenever you're done with that, that's when you verify the repairs. In this case, we would then at that point clear the codes. We would test drive the car. We check for pending codes, all that type of stuff. So anyways, does a scanner replace having a multimeter and knowing about electricity? No, it doesn't. It doesn't replace a fuel pressure gauge or anything else. It's just one more tool to your diagnostic toolbox that you need working on modern cars these days. Okay, and when I say modern cars, I mean cars within the last 30 years or so. So anyways, it kind of shows you some of the stuff that that tool can do. What I want to do is kind of pause this presentation at this point, and let's relate this back to our class and our Canvas web page. So what I'm going to do is I'm going to change my screen share, I think. There we go, new share. We're going to go back to the internet. I'm going to minimize that and kind of get some stuff pulled back around here. Let's see. Okay. Let's see. Just for whatever reason, it looks kind of weird, and we'll try it again. Hey, there we go. Okay, so if I go over here to modules, guys, if I go to modules and wait for it to load, and I'm going to minimize some of this stuff. We've done oil changes, precision measurement. I mean, we really have covered a lot of information this school semester. So our last two things here are electrical basics and basic onboard diagnostics. And I need to, let's see here. I'll go to this electrical basics assignment. What you'll see is on the assignment, there's all kinds of video clips of how to use the meter, how to test a car battery. Some of these are done by us. Other ones are just good ones we found on the internet. So you can learn about that stuff. We have an electrical presentation, and then we have this fillable form here that relates to, get that thing loading up. It relates to Leo here in the red shirt, some of his tests that he does, measuring for volts and that type of thing. Okay, so you can kind of fill that out as you're watching some of these videos, or you could do some of this stuff on your own car. In fact, some of the stuff we've already talked about tonight, like which lead is used for ground. Oh, that's the black lead, right? So if I get my little text tool up here, I can be like, okay, yeah, that's the black lead. When he tested battery volts, what was the setting on the meter? Well, I didn't see that video yet, but I know what it should be. It should be volts DC, right? So it'd be V with a line above it and a little dashed line, because it could be a pulsating DC. That is what that means, that dashed line. So volts DC. So I won't give all that stuff away, but anyways, so you can fill this out as you follow along with the presentations, under that electrical assignment. Let me clear out those. Drawings, guys. All right. So that's your week 15. It's all about electrical stuff. Okay. Week 16, if I go back to modules, week 16 is about scan tools, and I do have Ms. Cheryl Tashima put together a nice presentation similar to what I was just talking about with the OBD2 and stuff. She has a worksheet here under the assignment for you to fill out. And again, we're using the ELM 327 scan tool interfaces, but you don't feel like you have to buy a scanner interface. What you could do is like I said, go to your local auto parts store. They all offer like free code scanning, and you could see what they're doing. Take a couple pictures of that thing with your phone, and you can basically fill this worksheet out at your local auto parts store. Like I said, they all offer a free code scan. So that would be something, although these interfaces are inexpensive enough that I think they're good to have. Even like I'll keep one in my glove box. So if I'm driving my truck and something goes wrong. And so I have this choosing a scanner adapter. I put this little website link on here. Now I like this car scanner ELM app because it's a free app and it works equally good on Android versus iPhone. There's some other great apps, but some of them only work on Android or only work. So I picked this one for my scanner diagnostic class, but it has some good information on choosing adapters and what ones work and what ones don't work. You can see they talk about, there's several different ones, but they talk about this little Vicar one, and I actually have had really good luck with that one. So anyways, the information's there for you. I thought, it might be a lot to try to get your car scanned all in a few days. And so that's why I wanted to talk a little bit about the scanners tonight, so that, if this is something you want to do and you want to get to the auto parts store and do that last worksheet, you could kind of get a jump start on that. And get that activity done. It is pretty interesting to check for codes and look at the data. I mean, I always really liked scanner diagnostics. It's pretty cool stuff because you're tapping into the computer and seeing what information it has in there. And a lot of times that can get you going the right direction as far as establishing condition and figuring out what's wrong with the car. Okay. So these last 2 weeks of modules, one is related to electrical systems, and the other one is about your onboard diagnostics. And so that's why I wanted to talk enough about those to kind of get you going. Now, there is a little bit more about engine diagnostics that I'd like to get into, but what we'll do for that is we'll wait till next week, and I'll finish that presentation that we were on tonight and jump into some of those other diagnostic steps, like what's a compression tester, what's the importance of a vacuum gauge, and we'll look at the spark tester and measuring fuel pressure and stuff like that, things that kind of relate in. Okay, but the key concepts tonight are electrical testing. Here's a great little web link here. In fact, I'll just open up the extra window on how to use a multimeter. And I'll tell you, it's another good tool to have. And you don't have to get a real expensive one when you're getting started. You could have an inexpensive one like this right here and still do a lot of testing with it. And remember, this talks about volts, ohms, and amps. There's no juice. Everybody's looking for juice, but really, they just don't know their terms. What you want is you're looking for voltage. Maybe you're measuring the resistance of a component, you're measuring its ohms, or you're measuring amps. So I also tried to put some good website links on there for you to give you some good information on how to do some of these tests with the multimeter. Okay. And lastly, getting back to, what are we going to do next week? We're just going to kind of finish everything up. We'll look at the final exam, and which for some reason it should be in this module, but I don't see it. We'll look at the final exam and finish things out. I did want to point out this diagnose a no start little case study. This is a good example of the stuff we'll talk about next week, where maybe your car is older, it doesn't use a scanner. What are some of these other steps that you might go through to figure out what's wrong with your car, why it won't start? So here's the guy, he's checking for spark, he's checking for fuel, all that type of thing. He's looking for the crank sensor pin on the flywheel. And this is an old 1980s vintage BMW. So no OBD2 scanner on this one. Okay, so that's what we'll be getting into next week. So I will have some good information for you. As far as tech tips tonight, if you have a 1996 or newer vehicle, it's worth getting one of these. Put this on your birthday list, your Christmas wish list, something. It's worth getting yourselves a scantool interface because tapping into that scantool is really important. And then my second tip for you guys is get yourself a multimeter and always look at the voltage of the battery. A fully charged battery should have 12.6 volts. In fact, I'm going to type in battery SOC for state of charge. And I guess I better be a little bit more specific. Car battery, and it's made of lead and it has acid in it. So lead acid car battery state of charge. And let's look at a good graph for that. And that's a little hard to read. Not that one. All right, 13 volts. That's a little high. All these ones are a little bit. Here we go. This is a pretty good one. That's what happens when you're just searching around on the internet. So 12.6 volts is considered to be a fully charged battery. What you can see is that when it drops down just a little bit, 12.5, now it's only at 90%. 12.45, now it's down at 75%. Look at that. If I'm at 12 volts, my battery is actually really dead. It's not a linear scale. You would think 6 volts would be 50% charged of a 12 volt battery, but that's not the case. Okay, so one of the other important things, one of your other tech tips for tonight is if you have a car, if it doesn't start, or even if it's just running weird, it's always worth your time to measure that battery voltage. With the car off, it should be reading 12.6 volts or higher. If it's not, that indicates other problems. Okay, so those are your two tips for tonight. We'll wrap this thing back up on the home screen for our AT100 class. Remember, there's all different ways to go through this thing. You can click grades to see what assignments you haven't done or need to do. There's this to-do list on the side here. If I can get my drawing tool going here, there's this to-do list over here that you can use to see what assignments you have to do yet. all in all, you guys are doing really good. I've been seeing people do extra credit. I've been seeing people get their assignments turned in. It's absolutely fantastic. The grades are coming up, and a lot of the grades are really, really good. So that that makes me very happy. Another way you can go through there to see what assignments you need to do is just click the tab that says assignments and look at all the stuff. It lists out all the different assignments, and there is that final exam. I know why I couldn't see it, because I'm actually going to set it to open up tomorrow. Okay, so by tomorrow the final exam will open up and you guys can get started on that sucker. It'll be a little bit about every single thing we've talked about this semester. Okay, multiple choice, that type of thing. So anyways, any questions for tonight? Do you guys have any questions before I let you go? Clear out these drawings. We'll reset the screen. Well, all in all, like I said, you guys are doing great. I've been seeing your grades go up. I've been seeing you guys turn in assignments. I went through and updated grades as of yesterday. So if you did something today, I haven't maybe scored it yet, but everything up to like yesterday morning to Monday morning is current. And remember, there's way more extra credit that you can do. So like, I don't know how many points the class is total now, but there's way more points available than actually what you need to get an A in the class. So lots of you guys might do some extra credit to get your grade up, or you can end up where you have an A++ because of all the extra credit that you've done. So again, use that little grades feature, that little grades tab here on the side, and that will show you what you need to do to get this thing wrapped up and to finish strong. So
yeah, Ben, can I ask a question?
Certainly.
If the final opens up tomorrow, when is the final due in?
That's a great question. It's the last day of class. The last day of the semester is May 19th. Now, stuff doesn't close until May 21st. But the last day of the semester is May 19th. So that last week's kind of short. I had to have everything due May 19th, but I was able to keep everything open for a few more days. So if we go back to the calendar, it'll show you. So I'm putting in student view and I'm clicking the calendar. So what you can see is here we are on the 11th. Tomorrow that final will open up because that's when we're actually starting finals week, if you will. The semester ends on the 19th, but your assignments won't close out till the 21st. So if I click this final exam, you can see it should tell me, yeah, see it's open. It opens on May 12th and it closes on May 21st. So it's due on the 19th. You would lose like a couple points doing it on the 20th or the 21st. Not that many though. I think it's like 2% a day or something. That's standard built into Canvas. So guys, you really want to get everything done hopefully by the 19th. But if life gets busy, you have a couple extra days to get that stuff turned in. So we end up wrapping up pretty fast. And again, that's why I wanted to talk a little bit about the scanners tonight and give you enough information tonight that would allow you to do the assignment for this week and the assignments for next week as well. Even some of the stuff on the final, like I've talked about the bulk of that information. So, all right, good question. Any other questions for me, guys? All right, well, don't forget to check out that little grades tab. Keep those things coming in. If you have a problem with something, email me. I'll be happy to jump on and address that for you. And by and large, you guys are doing great as a class. So keep it up. And I look forward to seeing you guys next week for our very last class session, where we're going to finish out with some good tech tips on other diagnostics. So with that, we'll see you guys later.
Thank
All
you,
right.
Ben.
All right. Bye, everybody. Take care.